Hi children, welcome to the Physical Science Digital class. Now we are learning human eye and colorful world. In the previous session we learned about how the human eye functions, means how the eye able to form the image of an object in terms of its size, shape and color. And also we learned about how eye able to form the image of an object which is at different positions. So, means objects are differently positioned, situated different directions, but still our eye able to form the image. So, this is known as accommodation. About this also we discussed in our previous class, and also we learned about the vision defects. Those are myopia, hypermetropia and also presbyopia. So, these vision defects can be corrected by the using curved lenses, like myopia can be corrected by the biconcave lens and hypermetropia can be corrected by the biconvex lens. Presbyopia is due to aging effect, due to losing the accommodation with respect to the age. So, about all these topics we learned in our previous session. Now, in this session I am going to explain about the whenever the light is falls on the prism. Prism is a device which is a optic device which is like a lenses, like a concave and convex mirrors. So, whenever the light falls on the concave or convex mirrors, they reflect back, they may converge or they may diverge the light rays. And also whenever the light is incident on the convex lens or concave lens, the light rays are refract and converges or diverges. Now, in your 9th class you learned about the glass slab. So, whenever the light is falls on this, the light ray transmitted through this and emerge on from this side. And what happened you already learned. So, I am going to now show you the ray diagram. I want to recall you again once again children, see this ray diagram. See here children, this is the glass slab and drawn a normal line on the interface of the glass slab. So, whenever the light is incident on the glass slab, it transmitted, it refract at the first interface and as well as it refract at the second interface. When you extend the incident ray, so you can observe here children, incident ray and emergent ray both are parallel to each other, both are parallel. This activity is also done in your 9th class. So, this is incident ray and this is emergent ray. So, means whenever the light ray incident on the glass slab, it refract and emerge out, and this emergent ray is parallel to the incident ray, just they shift its path, just they shift its path. Now, observe this picture children. So, this is the glass slab. Here the both interfaces are parallel to each other. So, what happened, these two interfaces are angled, means like this. So, this will become a prism. Observe this one children. So, this is the prism, rectangular glass slab, and whenever the two parallel surfaces are angled, it will become a prism. So, what happened when the light ray is incident on the prism? Let us see with an array diagram. This is the prism. So, AB is one interface and AC is the another interface. So, this is a rarer medium and the prism material is taken as a denser medium, because of it is made up of a glass. When the light ray is incident on the AB interface, see here the light ray is incident on the AB interface, you have to draw the normal line at incident point. So, here the light ray is travelling from rarer to denser medium, that is why it bend towards the normal line. See here. So, the light ray bend towards the normal line, and again at the interface AC, the light ray is travelling from denser to rarer medium, that is why here the light ray refract away from the normal line. Finally, observe here. So, this is the incident ray and this is the emergent ray. So, when you extend the incident ray and extend back emergent ray, there is an angle between incident ray and emergent ray. This angle is known as deviation angle. Here children, light ray whenever it is incident on the interface of the prism, then it refract into the medium and again refract at the second interface, and again it changes its direction. In the case of glass slab, the emergent ray and incident ray are parallel to each other, but in the case of prism, the emergent ray and incident ray are angled. There is an angle, means here prism changes the direction of light. So, how can we use this prism in our life? Lenses can be used in our life to correct the myopia and hypermetropia, and also used to construct a telescope, microscope like optical instruments. And concave and convex mirrors also used to construct the optical instruments. Then what is the use of prism? So, prism can be used to change the direction of light in optical instruments like a binocular. In binocular we use the prisms to change the direction of light, and also prism is used to determine the refractive index of the material in our lab. How it is possible? So, we have a lab activity in our lesson. Now, I am going to show you how to do this lab activity. Material required for this lab activity: I need prism and a drawing board and drawing sheet. We need one scale and protractor to measure the angle, to draw the lines, okay. And also we need some drawing pins. So, what is the process of doing this experiment? So, first of all children, you have to draw the ray diagram, place the prism on the drawing board. Place the prism on drawing board, just to draw the outline for this prism. And you will get the image like this. This is the triangle. In this manner you have to place the prism and you have to draw the outline. And simply I am giving the corner symbols are A, B and C. With the help of protractor, draw the normal line on this AB surface. And also choose any angle. So, I am choosing here 30 degrees of angle. By using protractor, you have to draw a line at 30 degrees of angle to the normal line. So, you have to notice this children, you have to draw the line 30 degrees of angle to the normal line only, to the normal line. So, now like this you have to draw the 30 degrees angle of incidence. This is the ray which is drawn, which is light passes through pass along this line and incident on the prism. Okay, children. Now, how to measure the deviation angle? In what way the deviation angle can be measured? So, I am going to show this. So, first of all you have to take the drawing pins, 2 pins, take 2 pins and pin it on the incident line. At least the separation should be at least 5 centimeters, and place the prism in its place. Just now see the 2 pins from other side of the interface, from this side, and try to pin another 2 pins like this, and pin it on the paper like the 4 pins are in the straight line. The 4 pins are in the straight line. So, this is very difficult to explain you children. So, observe this one. See children, this is the way you have to pin it. But when you see the drawing sheet, the incident ray, the 2 pins, and as well as this is the emergent ray and the 2 pins are pinned here. So, when you see through this AC interface, you can observe like this. See children, these two pins are pinned on the incident ray and these two pins are pinned on the emergent ray, but when you see through the prism, they appears to be like the 4 pins are on the same line. So, like this you have to pin on the emergent ray. So, now remove the pins, and remove the prism and just draw the emergent line where we just join the 2 points where we pin on the drawing sheet. See here children. So, this is the emergent ray we drawn for this. Okay. So, now how to measure the deviation angle? See children, this is our prism and here the A is the angle between the two interfaces known as angle of prism. So, this is incident ray and you have to draw the normal line at the incident point, and this is the angle between normal line and incident ray, that is the angle of incidence symbolized with I1, and this is refractor ray inside the prism, and again it refract at the interface AC, and draw the normal line at the incident point, and the angle between this normal line and the emergent ray will be the emergent angle, and when you extend the incident ray and also extend back the emergent ray, the angle between these two is known as deviation angle. So, you have to measure the I1, I2 and D with the help of protractor, and now we have a table. So, you have to note all the values, that is I1, I2 and deviation angle, and repeat the activity with the different angles like 35, 40, 45, 50, 55, like this you have to repeat the experiment with different angles, because of the deviation angle is depend on the incident angle. So, observe this table children. So, this is a tabular form of our experiment, that is angle of incidence I1 which we take 30, 35, 40, 45, 50, 55, and angle of emergent you have to measure it by drawing the ray diagram, that is we do not know the values. When we do the experiment then we can know the values and enter the values, and angle of deviation also you have to measure with the help of protractor, angle between emergent ray and incident ray. So, what is the use of these values? How we use these values? There is a relation between incident ray and deviation angle. Whenever the incident angle is going on increases, there is a change in the deviation angle also. So, you can observe easily the variation between incident angle and deviation angle. You have to plot the graph between I and D. So, take the I values on x axis, take the deviation angle on y axis and plot the graph. So, this is known as ID graph. Here I took incident angle on x axis and deviation angle on y axis. When you plot the graph between the incident angle and the deviation angle, you will get the curve like this. So, means initially whenever the incident angle is less, the deviation will be more. So, whenever the I value is going on increases, the deviation angle is going on decreases like this. But at one point the deviation will becomes a minimum, and after then when you increase the incident angle again, there is a increase in deviation angle. So, this minimum deviation is possible at I1 equal to I2, means whenever the incident angle and emergent angle are equal, the angle of deviation will becomes a minimum. Okay. So, there is a relation between incident angle and deviation angles. Relation between refractive index, angle of prism and deviation angle. So, here n equal to sin a plus d by 2 by sin a by 2. Sin is a trigonometric function, you will learn in your mathematics children. So, n equal to sine of a plus d by 2 by sine a by 2. Here capital A is angle of prism, that is angle between the two interfaces. Here d is the angle of minimum deviation. So, by using this relation, that is n equal to sine a plus d by 2 by sine a by 2, we can calculate the refractive index of a material. Let us do an application problem for this formula, because of this formula is very important for our subject. How to use this formula and how to calculate the refractive index of a material. So, observe this problem, children. A prism with an angle A equal to 60 degrees produces an angle of minimum deviation of 30 degrees. Find the refractive index of material of the prism. Here the angle of prism is given as 60 degrees and angle of deviation given as 30 degrees. We have the formula, that is refractive index equal to sine a plus d by 2 by sine a by 2. Substitute these values in this equation. Then you will get like this, n equal to sine of 60 plus 30 by 2 by sine 60 by 2. 60 plus 30 is 90, 90 by 2 is nothing but 45. So, then refractive index n equal to sine 45 by sine of 60 by 2 means 30. So, n equal to sine 45 by sine 30. We know that, children, sine 45 is 1 by root 2 and sine 30 value is 1 by 2. So, substituting these values, n equal to 1 by root 2 by 1 by 2. Now, it will be 1 by root 2 into 2 by 1. So, now n equal to root 2 into root 2 by root 2, 1 root 2, one another root 2 gets cancelled because of these two are in division. So, what is the answer now? N equal to root 2. So, now the refractive index of prism is 1.414, as we know that root 2 value is 1.414. So, this is the refractive index of the material. In your daily life, you can observe some colors in the sky, some colors in your general activities, like observe this disc. There are so many colors appears on this disc. If you rotate this disc like this, you can observe so many colors: red, yellow, green, blue and violet. There are so many colors you can observe. So, what are these colors? From where these colors are coming? Okay. So, this is the prism. So, whenever the white light is incident on this prism, so it split into the colors. Yes. So, whenever the white light is incident on the prism, there are so many colors you can observe. So, this can be able to catch on the screen here. So, this is the screen. So, here there are so many colors, that is colors are red, orange, yellow, green, blue, indigo and violet. So, what is this phenomena? Splitting of white light into these colors is known as dispersion. This phenomena is known as dispersion. So, what is the reason behind this process? What is the reason behind this happening in this universe? So, let us discuss about this dispersion now. Children, whenever the light ray is incident on the mirror or a transparent material, the light ray reflect and refract. So, this reflection and refraction explained with the help of ray diagrams. So, we already did it in our previous lesson. There are so many ray diagrams are drawn. So, with the help of ray theory, we can explain reflection and also refraction. But when you come to the concept of dispersion, you cannot explain well with the help of ray theory. So, we have to adopt the wave theory. What is this wave theory? So, in your sound lesson, you learned about the wave, which has the frequency and which has a wavelength and which has the speed. So, yes, children. So, here also the light is considered as a wave, which is also known as electromagnetic wave. So, when light is considered as a wave, then the light has frequency and as well as the wavelength. So, depend on the frequency and wavelength, the light ray has a different colors. Whatever the visible, the light is observed with our naked eye, that light is known as visible light. This visible light consists of these all frequencies. So, what are these frequencies? Let us observe here. See here children, light is an electromagnetic wave. So, this is the light wave actually children. So, you do not know about this, but you can learn in your higher standards what are these. So, it is a combining of electric and magnetic wave. Speed of light, we have an equation in our sound lesson, that is speed of wave equal to nu lambda. Here it is light wave, that is why speed of light equal to V equal to nu lambda. Here nu is the frequency and lambda is the wavelength. Depend on the wavelength, the color of the light will be there. The speed of light in vacuum means in the space symbolized with C. The value of the C is constant, that is 3 into 10 to the power of 8 meter per second. So, children, this is our wavelength band, that is visible light. The range of wavelength of visible light is from 4000 angstrom to 7000 angstroms approximately, 4000 angstrom to 7000 angstroms. Near around the 7000 angstroms, the light is appear to be red, that is the light waves are red in color. So, the light waves which have the wavelength 6200, that is appear to be orange color, and the light wave which is in having 5600, about 5600 angstroms, that is yellow color, and for green color the value of the wavelength is 5150 and wavelength of the blue color is 4700. These values are around. So, there should be some small variation, and indigo has approximately 4400 angstroms and the violet has around 4100 angstroms. So, these are the wavelength values of the our visible light. If the light frequency or wavelength is equal to 4700, then it is blue in color, it is a blue color light. What is the relation between these wavelengths and dispersion phenomena? So, when the light ray is incident on the prism, it is splitting into the colors. So, whenever the light ray is in the air, so it is travel as a visible light only, simply combining of all these colors, means that light ray consists to all these wavelengths start from 4000 to 7000 angstroms. But whenever it is just enter into the prism, the colors are splitted. Why they splitted? Means different wavelengths, different color means different wavelengths chooses the different path. So, the refraction angle is different, the deviation angle is different. Why this happens? See the relation between wavelength and refractive index. The refractive index of medium n equal to C by V, this is learned in your 9th class lesson, that is n equal to C by V. Here the C is light velocity in vacuum, which is the value 3 into 10 to the power of 8 meter per second, and V is the light velocity in the medium. So, we know that the wave speed equation V equal to nu lambda. When you substitute this V value in the formula n equal to C by V, n equal to C by nu lambda. Here C and nu, that is light velocity in vacuum constant value and as well as the frequency is also constant. This is very important children. The frequency of the light does not change whenever it travels from one medium to another medium, means the frequency of light does not change whenever it refracts, only there is a change in wavelength. Okay children, and also there is a change in speed, there is no change in the frequency. So, here the light velocity in vacuum constant and the frequency of light does not change when it refracts. So, refractive index. When we remove these two constants, you will get here refractive index is inversely proportional to the wavelength. Refractive index is inversely proportional to the wavelength. This means the wavelength of red is greater than wavelength of violet. The red wavelength is approximately 7000 and wavelength of violet is approximately 4000. So, the value of wavelength of red is greater than the wavelength of violet. So, that is why according to our relation, that is refractive index is inversely proportional to the wavelength of the light, then the refractive index for red color is minimum and the refractive index for violet is maximum. So, that is why the red light, the red has a greater wavelength, hence it suffers low deviation, and violet has the shortest wavelength, hence it suffers more deviation. Like this, different colors, the remaining colors, that is yellow, green, indigo, other colors, blue. So, these colors have a different wavelength, that is why they have different angle of refraction, because of they have different refractive index. So, due to this reason children, the light waves chooses the different path, they have the different in angle, that is why they chooses the different path. Let us observe this diagram. I am only showing only red and violet color. In between these two colors, the remaining colors will be there. See children, here the red color less refract and the violet more refract, means the refraction will be more for violet because of refractive index is more. And the second interface again the refract like this. So, they appears to be split. Before incident on the prism, they travel along in the same path, in the same direction with the same speed, but whenever this light is enter into the prism, they changes their path because of there is a change in the speed. Why the change in the speed? Because of there is a change in the wavelength. There is a change in the wavelength, there is a change in the refractive index also. Due to this reason, the refraction angles will be different for different colors, that is why they appears to be splitted. So, let us review the points which we discussed in this session. The refractive index of prism is given by n equal to sin a plus d by 2 by sin a by 2. Here a is angle of prism, d is minimum deviation. Prism is used to change the direction of light in required direction and use it to find the refractive index of material. The splitting of white light into colors depending on the wavelength is called dispersion. Speed of light increases with increase in wavelength and vice versa. Refractive index decreases with an increase in wavelength. The refractive index of red is low, hence it suffers low deviation. The violet color has the shortest wavelength, its refractive index is high and hence it suffers more deviation. Children, to improve your learning, try to answer these questions. What are the uses of prism? Explain angle of minimum deviation. Draw the ray diagram showing deviation of light ray whenever it incident on prism surface. What is dispersion? What are the precautions has to be taken while doing activity showing dispersion of light using plane mirror? Children, this activity is given in your textbook. Read it and try to do it and try to answer this question. To improve your learning, for more applications, please visit SCRT website. In the next session, I am going to explain how the rainbow is formed and as well as why the sky appears as blue, sometimes it is in red, sometimes it is in white, and how the ocean is also appears as blue. Okay children, thank you.